Hello everyone. In today's video, I will be discussing about the ray diagrams for convex lens. For this, I have taken a sheet. Then you need to draw a principal axis of the convex lens, the center of the lens as optical center, mark the point F and 2F on both sides of the lens. The ray diagrams can be drawn by using two of the three special rays. So starting with the first one, I'll draw the first special ray and assuming this as an object. So whatever is the length of the matchstick, exactly at the same distance above the principal axis, I will be drawing a ray of light parallel to the principal axis. So this is the first special ray, a ray of light parallel to the principal axis. After passing through the convex lens, it will pass through the focus. And don't forget to put the arrows. So this is the first special ray. To demonstrate the second special ray, I will be using a straw and a board pin. So what I am doing is, once you have taken the straw, fix the center of the straw at the optical center using the board pin. So let us start with the first case and let us assume that the object is beyond the point 2F. Ensure that you always keep the head of the matchstick away from the principal axis. So the head of the matchstick becomes the top of the object and this becomes the bottom of the object. So the first special ray of light passing parallel to the principal axis, now it will pass through the focus. This straw will serve the purpose of the second special ray and we have to move it such that it will touch the top of the object and now it is passing through the optical center. Wherever these two will intersect, this point will denote as the position of the image of this particular object. So to denote the image, I will place another matchstick. If you compare the size of the image with that of the object, the size is smaller. So when the object is beyond point 2F of the lens, the image formed is diminished, it is inverted and it is real. Another important thing is the position of the image. So here you can see clearly that the object, when it is placed beyond 2F, the image is formed between F and 2F. Now let us discuss about case 2 when the object is at 2F. So now I am placing the matchstick at point 2F. We have already drawn the first ray, which is a ray of light parallel to the principal axis is passing through the focus. Talking about the second one, we have to show that this particular ray of light is passing through the optical center and it goes undeviated. And wherever the two meet, now we can see that they are meeting at this particular point here. So wherever the two meet, we will get the position, size and nature of the image formed. So here we can see that if the object is placed at 2F, the image will be formed at 2F. It is again real and inverted and it is exactly of the same size. So I have kept the another matchstick over here. So this shows that the size is exactly the same. Now let us discuss about case 3 when the object is between F and 2F. So this is the way you will be getting the setup. Now since there is a small gap left over here, so what are we supposed to do is we need to extend these two lines so that they can intersect. And after extending them, we find that they meet at a point beyond 2F. So what I can do is I can simply place this Now we can clearly see that the image formed here is inverted, real, and the size is enlarged or magnified. So when the object is placed between points F and 2F, the image formed is beyond 2F point. It is inverted, real, and magnified. Now coming to case number 4, when we have to assume that our object is placed at the focus of the lens. So this is the way you will be getting the setup. And we find that both the rays are parallel to each other. Now, when the object is placed at the focus, the image will be formed very far off, that is at infinity. It will be again real, inverted, and magnified in size. Now, let us talk about the last case where we have placed the object between the F and O points of the lens. Now, once you observe this, we can say that the rays are not meeting. So what are we supposed to do here is we have to extend them in the backward direction to a point where the two will meet. And the two rays are meeting at this point. So starting from here till the principal axis will be the position of the image formed when the object is placed between point F and O. So take it like this, and here we find that the image formed is erect. It is virtual because it has been formed by the apparent intersection of the rays, and it is magnified in size. So when the object is very close to the lens, then the image formed is virtual, erect, and magnified, and the image is formed beyond F point of the lens on the same side as the object is. So this case is entirely different from the other cases which we have discussed. Hope you have understood, and I feel that you will definitely try it. And one more important thing, that there is no need to cram up this particular topic. The only thing is that you need to practice it, and once you practice it on your own, which we call as learning by doing, the learning of the concept becomes more clear. So there is no need to cram up the things. You can just try out this particular activity. We don't require too much of things. We just require an A4 size sheet, sketch pen, straw, board pen, and matchbox. Thank you, and I hope that you all liked it.